Okay, quick video on the circle examples that was going to be today's class. So this is for the March 2nd content. Looking at center and radius of a circle, connection between the equation and the graph from various points of view on this document. Just several examples, similar to what you would see in this section in the book on circles. 21.3, I think it is. The form that we're looking for in order to go nicely between equation and graph is not quite what we have in these things. So I'm going to write out the general form that we're looking for someplace convenient so we know what we're looking like. And the big thing to get used to in this whole chapter is how do I take an equation, and we're not really solving it for one thing, we're just moving the equation around to make it look like one of these particular forms. So we've done that a little bit with y equals mx plus b stuff, but this gets a little more complicated than that. How do I move around an equation to match it up to a particular form? I'm still just rewriting things and doing things to both sides of the equation, but the thought process of what needs to be done is a little different. This one's kind of close to that form. It's almost there, except obviously the 16 is in our way. The 16 does not belong there if we're going to have just this. So I got to get rid of that, but that's this multiple of 16 that's on them, so getting rid of that would just be dividing by 16. That's going to have to divide out of every term in the equation on both sides. So that kind of distributes that way, and that'll get rid of both 16s. Now it's like, hey, we're lucky those were the same number, right? Well, if it's a circle, those have to be the same number. That's kind of giving you an indication of where we'd get a different conic section if they weren't. We'll get into that a little. But dividing that out, now I just have x plus 3 squared. Have y minus 3 squared. And this is 49 over 16. So that's going to be in the role of r squared here. So notice the minuses are already here. So this is what happens when k is 3. And this being an x plus 3, I'm thinking of it as subtracting negative 3. So my h is negative 3. So the center of the circle is at negative 3 comma 3. If r squared is 49 over 16, then r is 7 over 4. That came out kind of nice. So radius 7 over 4. Or 1.75. Okay. That's what we needed on that one. A little more algebra work when it's written out like this. We have to do the completing the square part. We got a bunch of terms instead, and I need to sort out my x and y stuff and make them into complete squares. So this is where the algebra gets a little more involved. But sort the terms and get some spaces here. I need perfect square there. And the y stuff is in this thing, and I need perfect square there. And I don't have a number term, so that's still just 0 on that side. But I'm going to do something to it. I'm going to do a couple of things to it. I need this to be a perfect square. X minus something squared. And I need this to be just y minus something squared. And the pattern is, this has got to be a 2. This is the divide by 2 and square it part. In order for that to be a perfect square, it's going to have to be x minus 2 squared so that your x terms come out right. And if it's going to be x minus 2 squared, it's got to have negative 2 squared right here, or plus 4. So I have to add the plus 4 to both sides of the equation. And then, same kind of thing with the y's. I'm going to have to do the same thing with the y's. This had a y on it. That was 18y. Divide that number by 2, you get negative 9. That's what's inside here. K is 9. Square it. I get plus 81. That's not there, so I got to add it to both sides of the equation. This is already equal to that. This is already equal to that now. The only work I got to do here is go ahead and put that together. So I got 85. Center is 2, 9. Both of those are positive this time. It's in the first quadrant, the center. And the radius squared is 85, so the radius is square root of 85. That's 9 point something. Didn't come out to a nice number here. The other direction's pretty simple. You got to understand it graphically, and then we can put it right into that form. So this one kind of tells you what h and k are already, but containing the origin. Containing means the circle actually goes through the origin. So thinking about the picture out here, way out here somewhere is 11, 16. Somehow I need a circle big enough that it'll go through the origin here, 0, 0. And if it's going through a point, I just know one point on the equation of it. So that's a little inconvenient, but I can write this down, see what I know and don't know. There's the form. This has got to be x minus 11 squared because that's the h. And this has got to be y minus 16 squared because that's the k. And then the r squared is what I don't know. So there's still one thing unknown. But if it's going to go through this point, that means the equation has got to be true if I put in this x and this y. That's what it means for this point to be on the graph or contained in the graph. Is that if I plug those in, it'll come out equal. So I can figure out the r squared kind of backwards by plugging those things in. This would have to be true for 0, 0. So 0 minus 11 squared and 0 minus 16 squared would have to equal r squared. And that's just a number now. That's 121. 256, 377 equals r squared. So the radius squared has to be 377. That's my equation. The radius is the square root of 377, but that's the equation for it now. This one's asked a little different. Not going to draw it, just going to think this through right here. If they're the ends of a diameter, then halfway between those points would have to be the center. So the midpoint here, this is a chance to use our midpoint idea. But they're both on x equals 5, so this is 5. And halfway between the y's is 0. Add them up and divide by 2. You get the midpoint there is 5, 0. That's the center. And then you can see the distance between this and those points. If those are on the circle and this is the center, we're talking about 3 units out. So the radius is 3. So I can just write out the equation now. Can have a 0 in here, that simplifies nicely. Radius is 3, so this is 3 squared. You could write it as x minus 5 squared plus y squared equals 9. If you want to multiply that out, you could, but this is fine. This is the equation in that circle. One more, this will be fairly quick because I'm running through these at full speed, but take your time on it. One more, I have to do the rearranging and the completing the square thing on this to sketch it. We're going to go ahead and draw this thing. So I need to find the center and radius to draw it. I mean, I could plug in numbers here, but that's a tedious thing. So getting it into my standard circle form would be useful. So again, sort them out. Leave some space. Y squared and minus 10y are the y pieces. And the other number I don't really want, so I'm going to move that to the other side to start with. That's -1, which looks fishy there, but I'm going to have to add some stuff in here now. So here I'm going back between that form and this form. Well, I'm going to get a different number there. We'll see what that ends up being. This is what it's got to be. The divide by 2 and square it is your next step. So this number divided by 2 is -1. Square it is +1. That's always positive when you square everything. So I'm doing a +1 on both sides. This divided by 2 is 5. -5 squared is 25. So this has to have a +25 added to it. So that all comes out to 25. I got a center at 1, 5. And I got radius is also 5. This is r squared. So the radius is 5 also. Now it's real easy to do a sketch on that. Plot the point. Keeping in mind that's not part of your graph, but it's the center that you're at. 5 units away from that in all directions. It's pretty easy to put the top and the bottom. And the left and the right, if you count that off, that's going to be at 6, 5. And -4, 5 is 5 units in either direction there. And if you mark those points, you can kind of see the box that it's in. Just draw the circle around through those. This one's going to end up tangent to the x-axis there. Okay, so the big question, well, one of the next big questions we could do on this What happens if this distance was a little different than this distance and we had a stretched thing instead of a circle? Or if I rewrite the equation, if I take that equation and divide by the 25, so this is equal to 1. What if those were two different numbers instead of the same number? Then my x squared and my y squared, I wouldn't be able to isolate them both like that. So I wouldn't be able to do this with it. But if they were, but this is the radius squared. What if these were two different numbers? There's sort of two different radius to it. So if you threw a what if in here and go, what if this was 16 instead of 25? Well, it does work kind of. One thing you might think of is that the y still goes with the 5 and the x kind of goes with a 4. Now this is 4 squared instead that I just made up. Okay, that's the change that I made. But that would do what you might think it would do on the graph. See, this is going to be at its maximum when this comes out to 5. So that's still happening at these points. The y's are the same. Sorry, when y is 5, and y is 10 or 0, that's still going to come out like that. Yeah, these points are the same. But the x would only go 4 units now. We'd have a smaller radius in the x direction. So we're going to start looking at things like that. Actually, Thursday, we'll start looking at things like that when instead of one radius, we have two different ones. We're going to keep them in the denominator like this and think about like a minor axis and a major axis. One of these is bigger than the other, so we can't call them both R. We're going to have some different letters to it. But you have one shorter radius, one shorter diameter, and one larger one. More on this Thursday. So next time we'll look at parabolas, which is a different situation, and then on Thursday we'll be back on ellipses. Tomorrow I'm going to do the video ahead of time and have a video up ahead of the 12:20 session on YouTube. On Thursday, hopefully things are smooth here and we'll try to be back in sort of live class Thursday. All right.